You've selected the submenu for a practical guide on undertaking workplace sound level measurements. Undertaking sound level measurements in the workplace for the first time can be a challenge. However, it needn't be, given some guidance and practical advice. We've broken down the process into a number of short sections, covering sound level meters versus dose badges, meter settings, measurement types, broadband and octave band, measurement positions, hearing protection, noise surveys. Unless the noise levels in your workplace don't fluctuate and are below legal limits, it's most likely that you'll need to use both a sound level meter and a dose badge when undertaking a noise assessment. Both instruments have their strengths but also weaknesses. For example, it would be difficult and potentially quite hazardous to measure the noise exposure of a forklift truck driver or Formula One mechanic when changing the wheels and tyres in a pit stop using a sound level meter. It would also not be possible to measure the sound levels at different octave bands using a dose badge. However, dose badges are useful at calculating the overall noise exposure, or dose, of a worker for a complete shift. They're unobtrusive and simple to operate. Sound level meters, though, especially if they have the ability to measure the sound levels at different frequencies or octave bands, allow a more detailed analysis and investigation to be undertaken of specific loud events. The ability to measure the sound levels at different frequencies is also invaluable when selecting hearing protection. The assumed protection values stated by the manufacturers vary quite considerably at different frequencies. So in summary, the dose badge should be used to give you a good basic indication of a worker's daily noise exposure or dose. This should then be supported by a more detailed analysis of the measurements of any specific events or peaks using a sound level meter. It's important to set the correct range, otherwise the sound level meter may be overloaded or underloaded, i.e. not record a measurement at all. The instrument display will report over or underloading by displaying a warning symbol. The range to use is very much dependent on whether the noise is generally of a static or fluctuating nature. As a starting point and general rule, for fluctuating noise, use a scale where the average level is in the middle of the scale. For static noise, use a scale where the average reading is approximately 2/3 of the way up the scale. Sound level meters often have a number of different frequency and time weightings, which can be used in different situations. For measurements that are to comply with, for example, the noise at work regulations, noise should be measured using LEQ with the A frequency weighting. The measurement of the peak sound pressure should be made with C frequency weighting. If in doubt, always refer to the regulations that you're required to meet. For octave band measurements, use the Z or linear frequency weighting. A broadband measurement is, as its name suggests, a measurement of noise level across a broad spectrum of frequencies. If the noise you're required to measure doesn't fluctuate much and is significantly below legal limits, then using broadband measurements as the basis of your noise risk assessment is probably fine in a lot of cases. However, for fluctuating sound or high noise levels, measuring and understanding the pitch or frequency of the noise is just as important as the loudness. Some machinery can emit high noise levels at very high frequencies, for example an ultrasonic cleaner, or very low frequencies, for example a rumbler. In the case of hearing protection, the assumed protection values or attenuation stated by the manufacturers vary at different frequencies. The ability to measure the sound levels at different frequencies is therefore essential when selecting hearing protection. When using a sound level meter, the following points should be followed. Measurements should be taken at the operator's ear position, preferably in the absence of the operator. If the equipment can't be used without the operator, then place the instrument 10 centimetres from each ear. You only need to report one measurement if the result is the same at each ear. If the sound level in the work area is generally the same, measurements should be taken at 5 or more workstations representative of the distribution of workers. In the case of noise predominating from a single machine or line, measurements should be taken at the operator's position and of 3 or more of those nearby. If any measurement is recorded at or above 85 dBA, then the sound level should be measured at every operator's position. When taking measurements using a dose badge, it should be mounted on the shoulder of the wearer within 10 centimetres of their left or right ear. Make sure that nothing can touch the dose badge, otherwise the measurements may be compromised. Hearing protection should not be considered as a long-term solution to protecting workers from noise exposure. The reason for this statement is twofold. Firstly, the performance of hearing protection is very dependent upon the fit and condition of the protection. Incorrect fitting of earplugs, for example, can reduce their performance by as much as 22 decibels. It's essential, therefore, that instruction is given before use. Earmuff performance depends upon the effectiveness of the cushion seal around the ear. Any relaxation of the stiffness of the headband will reduce the seal pressure, resulting in reduced attenuation. Perspiration will, over time, harden the surface of the plastic seals, making them less effective. Muffs should be kept in good condition, and the seals cleaned regularly and replaced when they harden. And secondly, wear rates. If hearing protection was not worn for 1 hour during an 8-hour shift, the maximum protection that can be achieved is 9 decibels, irrespective of the performance of the protector. There are many different types of hearing protection, but by far the most important requirement for protectors is comfort rather than absolute performance. In reality, comfort usually means choice, as personal preferences differ. The principal aim of a factory noise survey is for it to be carried out in a reasonable time frame, with the results communicated to management using a report with actions and timescales. In most cases, noise surveys should be carried out every 2 years or soon as partial surveys if an area changes due to, for example, a new piece of equipment or process. The object is to assess the risk to personnel, so don't bother with walkways or areas where no one works. The measurement results should be marked up on an up-to-date factory floor plan. Consider segregating areas into hearing protection zones if this is appropriate. Ensure the drawings, and therefore areas of the factory, are marked accordingly. For large sites, it may be prudent to undertake a pre-survey survey to identify the noisy areas. Any area that records less than 80 decibels when the meter is set to A-weighted slow is likely to have an 8-hour LEQ of less than 80 decibels and can largely therefore be ignored. Calibrate the meter before and after use. Check the battery level both initially and regularly during measurements. Use the windshield on the microphone even indoors. This will protect the sensitive element against moisture, dust and mechanical impacts. Familiarise yourself with the instrument settings in your office. Referring to the manual in public does nothing for your credibility.